when working with a 600-volt, 600-amp bus bar, ensuring safe clearance distances from surrounding equipment like rack systems, L lines, and non-flammable gas lines is critical. Several codes and standards provide guidance, but it's crucial to remember that local jurisdictions and the specifics of your installation can influence the requirements. Always consult with qualified electricians or engineers to determine the appropriate clearances for your situation. The National Electrical Code, or NEC, specifically addresses busway clearances. According to NEC 440.24 FR, exposed busways must have a minimum clearance of 1 foot from any lighting fixtures or other equipment that is likely to require examination, adjustment, servicing, or maintenance while energized. This 1 foot clearance is designed to provide safe access for qualified personnel to perform necessary tasks on or around the busway without increasing the risk of electrical shock or arc flash. NEC 440.24b further emphasizes the importance of adequate working clearances around electrical equipment. It states that these clearances must be sufficient to provide access and working space for the intended use, mounting, maintenance, and servicing of the equipment. This requirement aims to prevent hazards to personnel during installation, maintenance, and operation. It's important to consider not only the immediate space around the busway, but also the space needed for workers to maneuver tools and equipment safely. Beyond the NEC, other codes and standards offer additional recommendations. NFPA 70E, the standard for electrical safety in the workplace, recommends a minimum clearance of 1 foot from energized bus conductors. This standard focuses on protecting workers from electrical hazards and provides detailed guidance on safe work practices and personal protective equipment, or PPE. IEEE, the Guide for Safety in Electrical Installations, suggests a more conservative minimum clearance of 10 feet from the face of the busway to any combustible material. This recommendation is aimed at preventing fires that could result from electrical faults or overheating. While 10 feet may seem excessive in some cases, it provides a significant buffer against the risk of fire, especially in environments where flammable materials are present. ANSI/IS AMNAS 5.1 addresses electrical equipment used in Zone 0, 1, and 2 hazardous locations. It requires that electrical equipment in these locations be installed to minimize the risk of ignition of flammable materials. This standard is particularly relevant in industrial settings where flammable gases, vapors, or dust may be present. The specific clearance requirements for electrical equipment in hazardous locations depend on the classification of the zone and the properties of the flammable materials involved. When determining appropriate clearances, consider several additional factors. Firstly, the voltage and current rating of the bus bar are critical. Higher voltage and current levels generally require greater clearances to reduce the risk of arc flash and electrical shock. Secondly, the type of enclosure or insulation used for the bus bar can affect clearance requirements. Enclosed busways may require less clearance than exposed bus bars. Thirdly, the presence of other equipment or structures near the bus bar can influence clearances. Obstructions may require increased clearances to maintain safe access and working space. Fourthly, the environmental conditions in the area should be taken into account. High humidity, temperature extremes, and corrosive atmospheres can all affect the performance and safety of electrical equipment. Fifthly, local codes and regulations may impose additional clearance requirements. It's essential to consult with local authorities to ensure compliance with all applicable codes. To put this information into practice, consider a scenario where a rack system is being installed near a 600-volt, 600-amp bus bar. The first step is to consult the NEC to determine the minimum clearance requirements. According to NEC 440.24 FR, a 1 foot clearance is required from any equipment that is likely to require examination, adjustment, servicing, or maintenance while energized. Next, consider the recommendations of NFPA 70E and IEEE. NFPA 70E also recommends a 1 foot clearance, while IEEE suggests a 10 foot clearance from combustible materials. Given these recommendations, it would be prudent to maintain at least a 1 foot clearance from the rack system to the bus bar, and a 10 foot clearance if the rack system contains any combustible materials. Finally, consult with a qualified electrician or engineer to ensure that the clearances are adequate for the specific installation. They can assess the risks associated with the installation and recommend additional safety measures as needed. In the case of air lines or non-flammable gas lines, the primary concern is to prevent damage to the lines that could result in leaks or other hazards. It's important to ensure that the lines are properly supported and protected from physical damage. Clearances should be sufficient to allow for inspection and maintenance of the lines without creating a hazard to personnel or equipment. While the NEC and other electrical codes may not specifically address the clearance requirements for air lines and gas lines, it's still important to follow industry best practices and consult with qualified professionals to ensure safe installation and operation. Remember that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Electrical work can be dangerous, and it's essential to take all necessary precautions to protect yourself and others from harm. Always consult with qualified electricians or engineers to ensure that your electrical installations are safe and compliant with all applicable codes and standards. Understanding the relevant codes and standards such as the NEC, NFPA 70E, IEEE, and ANSI/IS 5.1 is crucial for ensuring electrical safety in any workplace. These codes provide specific guidelines and recommendations for the installation, maintenance, and operation of electrical equipment, including bus bars. However, it's important to remember that these codes are not a substitute for professional judgment and experience. Qualified electricians and engineers have the knowledge and expertise to assess the risks associated with specific electrical installations and recommend appropriate safety measures. They can also help you navigate the complex web of local codes and regulations that may apply to your project. Therefore, when working with a 600-volt, 600-amp bus bar, always consult with qualified professionals to ensure that your installation is safe, compliant, and reliable. By following this advice, you can help prevent electrical accidents and protect your workers and equipment from harm. Proper planning, careful installation, and regular maintenance are all essential for ensuring the safe and reliable operation of electrical systems. Don't take shortcuts or cut corners when it comes to electrical safety. It's always better to err on the side of caution and consult with qualified professionals to ensure that your electrical installations are up to code and properly protected. The cost of a professional consultation is a small price to pay compared to the potential consequences of an electrical accident. In addition to consulting with qualified professionals, it's also important to provide adequate training to your employees on electrical safety. Workers who are properly trained are more likely to recognize hazards and take appropriate precautions to prevent accidents. Training should cover topics such as lockout/tagout procedures, personal protective equipment, arc flash safety, and emergency response. Regular refresher training should also be provided to ensure that workers stay up to date on the latest safety practices. Electrical safety is a shared responsibility. Everyone in the workplace, from management to employees, must be committed to following safe work practices and preventing electrical accidents. By working together, we can create a safer and more productive work environment for all. Furthermore, remember that electrical codes and standards are constantly evolving. It's important to stay informed about the latest changes and updates to ensure that your electrical installations remain compliant and safe. Subscribing to industry publications, attending conferences and seminars, and participating in professional organizations are all good ways to stay up to date on the latest developments in electrical safety. In summary, maintaining safe clearance distances from a 600-volt, 600-amp busbar requires a thorough understanding of relevant codes and standards such as the NEC, NFPA 70E, IEEE, and ANSI/IS 5.1, as well as consultation with qualified electricians and engineers. By following these guidelines and taking all necessary precautions, you can help prevent electrical accidents and protect your workers and equipment from harm. Remember, electrical safety is not just a matter of compliance, it's a matter of life and death. By prioritizing safety in all aspects of your electrical work, you can create a safer and more productive work environment for everyone. I would like to elaborate further on specific sections of the NEC that are relevant to bus bar installations and clearances. Firstly, Article 368 covers busways, which are prefabricated electrical distribution systems consisting of bus bars enclosed in a protective housing. This article provides requirements for the installation, support, and grounding of busways, as well as the clearances around them. Secondly, Section 110.26 of the NEC addresses working space about electrical equipment operating at 600 volts, nominal, or less to ground. This section specifies the minimum depth, width, and height of the working space required in front of electrical equipment, including bus bars. The depth of the working space depends on the voltage to ground and the condition of the installation. Thirdly, Table 110.26 AM provides the minimum clear distances for working space based on the voltage to ground and the conditions of the installation. Condition 1 refers to exposed live parts on one side and no live or grounded parts on the other side of the working space, or exposed live parts on both sides effectively protected by insulation. Condition 2 refers to exposed live parts on one side and grounded parts on the other side of the working space. Condition 3 refers to exposed live parts on both sides of the working space, not guarded as provided in Condition 1, with the operator between. It is crucial to select the appropriate condition based on the specific characteristics of the bus bar installation. Fourthly, Section 110.33 addresses working space and guarding for equipment operating at over 600 volts, nominal. This section specifies the minimum dimensions of the working space and the required guarding for electrical equipment operating at higher voltages. The working space must be adequate to allow safe operation and maintenance of the equipment. Fifthly, Table 110.34 provides the minimum clear distances for working space about electrical equipment operating at over 600 volts, nominal. This table specifies the minimum depth of the working space based on the voltage and the location of the equipment. In addition to these specific sections of the NEC, it's also important to consider general requirements for electrical safety, such as proper grounding, overcurrent protection, and the use of personal protective equipment. Grounding is essential for providing a low impedance path for fault current to return to the source, which helps to prevent electrical shock and equipment damage. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Personal protective equipment, such as gloves, safety glasses, and arc flash suits, is essential for protecting workers from electrical hazards. When working with a 600-volt, 600-amp bus bar, it's crucial to follow all applicable safety procedures and use the appropriate personal protective equipment. Electrical work can be dangerous, and it's essential to take all necessary precautions to protect yourself and others from harm. Always consult with qualified electricians or engineers to ensure that your electrical installations are safe and compliant with all applicable codes and standards. Remember that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Electrical work can be dangerous, and it's essential to take all necessary precautions to protect yourself and others from harm. Always consult with qualified electricians or engineers to determine the appropriate clearances for your specific application and to ensure that your electrical installations are safe and compliant with all applicable codes and standards. In addition, consider the specific requirements of the equipment being installed near the bus bar. Rack systems, airlines, and gas lines may have their own clearance requirements or safety considerations that need to be taken into account. For example, rack systems may need to be grounded to prevent static electricity buildup, while airlines and gas lines may need to be protected from physical damage or corrosion. It's also important to consider the potential for future modifications or additions to the electrical system. If there is a possibility that the bus bar may need to be expanded or upgraded in the future, it's important to plan for adequate clearances to accommodate these changes. This may involve leaving extra space around the bus bar or using flexible busway systems that can be easily reconfigured. Regular inspections and maintenance are also essential for ensuring the continued safety and reliability of the bus bar installation. Inspections should be performed periodically to check for signs of damage, corrosion, or overheating. Maintenance should include cleaning the bus bar, tightening connections, and testing the insulation resistance. Any problems that are identified during inspections should be promptly corrected to prevent potential hazards. By following these guidelines and taking all necessary precautions, you can ensure the safe and reliable operation of your 600-volt, 600-amp bus bar and protect your workers and equipment from harm. Remember, electrical safety is an ongoing process that requires vigilance and attention to detail.